That's what we have for 7.4. The area of a triangle is 1/2 times base times height. In this section, we will be dealing with 3 cases. Okay, what if we have 2 sides and included angle? That's what I'm about to do right now. We will derive the formula and then use the formula. Okay, suppose then I have a triangle with known 2 sides and the other side is unknown. Okay, so let's say I know this is angle A, this is vertex B, vertex C, so this is side B, this is side C. Now suppose what we know is 2 sides and included angle. Okay, how do we find the area? Now we know from earlier the area of a triangle is 1/2 times the base times the height. Now in this case I can use my B as a base. Okay, now the thing is, how about the height though? How about the height? Now then I look at this right triangle here. I look at that right triangle. Notice that sine A, let me write it here, sine A is equal to the height over C. Therefore, the height is side C times sine A. Okay? Now, that's what I will use here. This height here is now become 1/2 times B times C sine A. Notice that the play of the variable BC angle A. Okay. In other case, if I kind of like permute the notation, 1/2 AC sine B, 1/2 AB sine C. Okay, that's the permutation of the formulas. If we have 2 sides and included angle. Now, I wonder if you remember, let's do this one question first. For example, I have a triangle as angle, side A is 3, side B is 7, and angle C is, let's say, 40 degrees. Then what is the area of the triangle? Area of the triangle will be 1/2 the product of 2 sides times the sine of the included angle. I get 6.74927 units. Okay.
Is it unit squared?
You can say unit square. Okay, now that's example 1. Now, do you remember the stop sign problem? The one we have last time, the stop sign?
Yes.
Yeah, do you remember what's the radius?
The radius was 10. 10 centimeters.
10 centimeters. So suppose I have a stop sign whose radius is 10 centimeters. So the radius here is from the center to the vertex, and that's a regular octagon. Okay, the stop sign. Now find the area of that stop sign. Area of that stop sign of that octagon will be 8 times, because there are 8 triangles, right? Okay, area of each triangle. Okay, now what is the area of each triangle? Now the area of each triangle is 1/2 times, you see that you have, each triangle looks like this, right? So the two sides are 10. Now how about the included angle? That's 360 degrees
It's
divided
45
by,
degrees.
that's 45 degrees. So this will be sine 45 degrees. Okay, so this is 400. That's 400 times square root of 2 over 2. That's 200 square root of 2 centimeter squared. In fact, we can actually create a formula for an n-gon. And regular n-gon. Regular n-gon. So it's like if you have 4 sides, 5 sides, you call that pentagon. If you have 6 sides, you call that, what's that? If 6 sides? Hexagon, right? Okay. 8 sides, octagon, 10 sides, decagon, whatever n-gon. Okay, regular n-gon with radius r. What is the central angle?
Maybe 360.
The total angle, central angle is 360 divided by
The number of
sides, n, right? Okay, so the area of each triangle, will be 1/2 times the product of 2 sides, which is r and r, sine 360 degrees over n. Therefore, the area of n-gon, regular n-gon, will be n times 1/2 times r times sine of 360 degrees over n. That is nr squared over 2 times sine 360 degrees over n. Okay, that's the formula. Okay. Let's do some problems from the book using this formula before I go. By the way, beside that area of triangle that we learned long time ago, this is the second most often area of triangle being used. For the formula, yeah, this is the second most often formulas being used. Okay, let me ask you to try, for example, number 4 on page 347. That says that A equals to 76.3 centimeter. C is 42.8 centimeter. And then B is 16.3 degrees. Find the area of such triangle. Okay, I'll give you 2 minutes maybe. Write down the formula first and then plug in numbers, then compute. That's how you do it. That's 1/2 times 76.3 times 42.8 sine 16.3 degrees. Then I go on with my calculator.
458.27822.
458.
58, yes. 0.27822.
Centimeters squared. Can anybody else confirm? Wait, hold on. Is it right? Oh yeah, that's right. Okay. At least it seems right for me. Okay. Now that's for if we know two sides and included angle. Yeah, you will know that that angle is included if the variable, the notation, okay, is different from the other two. You see? Okay, it's different from the other two. Now let's see the second part. Part 2. What if we have two angles and one side, an included side? Now you will see for this formula, you will see for the formula that we will develop, it actually comes further from the formula we get in part 1. So suppose I have this equation here. Okay, and let's say A is known, B is known, and side C is known. Okay, this is the height. Let's call it that way. That's the setup. Okay, that's not really the setup. But anyway, let's start with this equation here. Now we have known earlier. Suppose I know A and B and C. Then the area from part A, from 1, we know that area is equals to 1/2 BC sine A. Okay. Now suppose we actually don't know B. Suppose we don't know B. Suppose we don't know B, but we know angle B. So we know this guy here, yet we don't know this guy. Okay. We know those two angles and the included side. Okay, so what I will do then is I will use law of sine to help me with that. To get me to get the B.
B over sine B equals A over sine A, right?
Okay, so B over sine B. Actually, I prefer that the other way around. Sine B over B equals to A sine A over A. But the thing is, will this give me what I want to?
It will, because then we can cross multiply and then we leave the B by itself. And then we plug that back into the what we don't know for B.
Okay, so let's see. So B sine A equals to A sine B. That's not really what I want though. That's not really what I want. Because I don't know A. I don't know A. A is not what I know. Let's change that story. Let's change that story. Or instead of sine B over B equals to sine A over A, I know C, right? So instead of using these, I use side C and angle C. How about that? But Thomas, we don't know angle C. Don't worry. Don't worry. So C sine B equals to B sine C. Is it right? Okay, so B is equal to C sine B over sine C. Now notice that if I know A and B, then angle A and B, then angle C is actually something coming for free, right? C is coming for free. Okay, so now I go back to the formula, the area of that triangle now. The area of that triangle now becomes 1/2. I will replace the B by C sine B over sine C times sine C sine A. C sine A. So this is equals to 1/2 C squared sine A sine B over sine C. Is it okay so far? Now that's actually the type of formulas our textbook actually developed. So for this section, if you take a look in our textbook will write it this way. 1/2 A squared sine B sine C over sine A. Or 1/2 B squared sine A sine C over sine B. Or the one we just had, 1/2 C squared sine B sine A sine B over sine C. Okay. Now that's what our textbook does. I want to improve this formula a little bit. Okay, I want to improve this formula a little bit. But by following observation, we know that A plus B plus C equals to 180 degrees, right? Okay, so angle A is equals to 180 degrees minus the sum of B plus C. Are you with me?
Yes.
Okay, now what I want you to realize is the following. Notice that this is actually the transformation we have from quadrant 2 to quadrant 1. When it comes to sine, they are actually the same. Sine A equals to sine 180 degrees minus B plus C. Okay. But at the same time, we know 100 sine of 180 minus blah is sine blah. Okay, such that we can now update this formula. I can update that formula and say that the area of a triangle equals to 1/2 a squared times sine b sine c over sine of the sum. Okay, of course, we still can use this though, don't get me wrong. We still can use this. Basically, if you want to use that, then once you get two angles, find the other one. Okay, while the formula I just have here, I don't need to find the other angle. Okay, now you can use either one formulas. Okay, you can use either one formula. So the one underneath here, for example, you can replace that with sine of a plus c. You can replace this by sine of a plus b, like that. Okay. Now suppose, for example, number 8. Angle A, I'm sorry, angle B is angle B is 57 degrees. Angle C is 31 degrees. And then side A is 7.3 meters. And how about the area? The area of the triangle will be 1/2 times the side square times sine 57 degrees. I need to use formula first. Sine B sine C over sine A. Okay, but I will just use sine B plus C. No, I'm not saying that A equals to B plus C. That's not what I'm saying. No, they are not. They are not. They are not the same. But when you apply sine, they becomes the same because B plus C is equals to 180 degrees minus A. Okay. Plug that in. This is 7.3 squared sine 57 degrees sine 31 degrees over sine 57 degrees plus 31 degrees. Then 7.3 squared divided by 2 times sine 57 close parentheses times sine 31 degrees divided by sine 88. I get 11.51625 square meter square. That's for number 8. You try number 10. Try number 10. Number 10, angle A is 110.4 degrees. Angle C is 21.8 degrees. And they give us side C here. Side C is 240 inches. So in this case, you need to first find angle B to work. Okay, you need to first find angle B. But you have two angles, so the third angle should be easy. Okay, I'll find the area of that triangle. Okay, maybe 2 minutes. So I need to find angle B first. So this is 132.2, huh? 132.2, so B is 47.8 degrees.
Yep.
Okay, so the area of the triangle will be 1/2 times C squared sine A sine B over sine C, since I have the C already.
I got 53,847.078.
Okay.
078. And it just stopped there.
Okay. So 240 squared divided by 2 times sine 110.4 times sine 47.8 divided by sine 21.8. Yes, that's what I have to. The units will be square inches. Okay, that's for number 10. Now, so again, you need to memorize the formula though. Okay, you need to memorize formula. Since it's open book, then I can tell you which one you need to memorize. The one you really need to memorize is, of course, the basic formula here. This one you have to memorize. Okay, if I know that you don't memorize this formula, I will be yelling at you for the next one week. Memorize. Okay, then the second formulas you need to memorize, if you need to memorize, is this formula here, and of course this thing's just the variation. Okay, now the two angles and one included side. I know that a lot of even calculus students, they don't memorize it. So at least you have exposed to that, and in the test you can do that. It's presumed to be open book, right? Okay, even though when you take the pictures and send it to me, please don't show me the pictures. In the test that I gave, I don't remember which test was that. My pre-calculus class, somebody turned in this kind of picture, like that's the test, right? Okay, but then the book was actually open here. You can see the shadow of the book. And there's other tests here, like my old test. I have to penalize that person 10 points because of that. Okay? Even if you do so, don't let me see it, please. Okay? Yeah, don't let me see it. On the other hand, if there are so many formulas you don't memorize, it will slow you down tremendously during a test. That's why there are some formulas show up very, very often. I will tell you, oh, memorize this, memorize that, memorize this, memorize this. Okay? Now, next, the third case, what happens if we have three sides? Three sides of a triangle. Three sides, oops. Three sides of a triangle. So suppose I don't know any angles, but I know all three sides. So this is, let's say this is A, B, and C. Okay, now, then the area of a triangle will be given by, I will not derive this formula. The derivation is actually in the book. Okay, they call that Heron's formula. They call that Heron's formula, which says the following: the area of the triangle equals to equals to the square root of s times s minus a, s minus b, s minus c, where s is semi-perimeter. That's 1/2 times a plus b plus c. That's why they call that s, that stands for semi-perimeter. Half of the perimeter. Okay, now suppose for example, I have side A equals to 10, side B equals to 12, and side C equals to 14. Find the area of a triangle.
We first do the semi-perimeter, correct?
That's right. So first we do the semi-perimeter. That's half of 10 plus 12 plus 14. I believe that's 30, 65 by 2, that's 18. So the area of the triangle will be the square root of 18 times 18 minus 10, 18 minus 12, 18 minus 14. And then I will simplify that square root of 18 times 8 times 6 times 4. Now, of course, when you compute this, try your best to not to use calculator too early. At times I will, if I think it's actually doable with a nice number, like maybe with radical, then I may ask you to do so. Okay, now to compute that in a nicer way, you may want to do prime, factor it this way, like this. The 18 is actually 9 times 2, right? Okay, the 8 is 4 times 2. And then you have 6 times 4. Okay, this is the 18. And this is the 8. Okay, now the reason I break it up that way because of the following. What is square root of 9?
3.
3. Square root of 4?
2.
Square root of this 4?
2.
2. And then we have square root of 2 times 2 times 6, right? Okay, now this is 12. But I can pull another, this is square root of 4. There's another 2 coming out. So that's 24 square root of 6. Okay, if you possibly do that, like in this case, I have nice numbers. But if the numbers are ugly, like with a lot of decimals, then just do it with calculator. Okay, now let me ask you to try question number 16. Try number 16. Number 16, I have A is 48 yards. B is 75 yards. And C is 63 yards. 1, 2, 3. 3 minutes. I just work it out. I thought that during your break, so that's what you get supposed to be, right?
Yes.
Let me try if I can improve the result without using calculator. Let's see, this is square root of, this is 31 times 3, 45 is 9 times 8, 18 is 9 times 2, 30 is, let me take the 3 out. So 3 times 3 under square root give me 3 outside. Okay, and then 9 times 9 under square root give me 9. Okay, what else?
The 8.
8 and 2, huh? 8 and 2 is 16. Under square root, that's 4. And then square root of 310. That's actually the furthest I can go. So 36 times 3, that's 108 times square root of 310. Let me check. Square root of 310, 17 something times 108. Why I get something else?
I think
No.
the 8. I
So it
think.
should be 5, huh? It should be
Yeah.
5 here.
Yeah, 5.
Okay, so that's 5 here. Good thing I check. Otherwise, I won't realize that. Okay.
You can take out a 5 instead, right?
Huh? Yeah.
We can take out a 5
together with the 10 later on. Actually, no need. I can do. Hold on. Let me erase this thing first. And this guy. So I'm good that far. And then I think I will do this. 5 times 2 times 10, that's 100. Right?
Yep.
So that's square root of 100 is 10. The leftover square root of 31. So this is 270 square root of 31. Square root of 31 times 270. Yep, exactly the same number. Okay, but in your test, just use calculator if the number is big or with the decimal. Okay, if the number is small, of course, try to get the exact value. You will know that I want the exact value if I say find the exact area. Okay, if I say find the exact area, then it means you need to do some more algebra. Okay, let me end this section with suggested homework. Your suggested homework for this section is number 1 to number 21. Okay. Now, last time I already asked you to read 8.1, but that 8.1 has no trigonometry. That 8.1 has no trigonometry. So I'm afraid that I don't have enough time. I would like to do 8.2 right away, which actually doable without 8.1. But of course, if you know what 8.1 is, it gives you more background for your 8.2. Now, what is 8.2? 8.2 is...
Is there any suggested homework you want us to do for 8.1, just so we could practice?
No need. As long as, okay, let me say for 8.1. The thing is, I don't ask questions from 8.1 in my test. If I do, that would be a kind of like a bonus question thingy. So 8.1 that, and then 23. 63. Just do the every other odd. Just do every other odd. So that should be around 15 or 16 problems there. Okay. Now I'm not doing that. If I think on Wednesday next week, I should have some time extra, and hopefully, or on Monday, if I have some time extra, then I will do some problem from this 8.1. But most of them actually on the easy side. Okay. But for me to go on to 8.3 on Monday, I need to do 8.2 right now. Okay, that's why I kind of rushed to 8.2. What is 8.2? It's a trigonometric form of complex numbers. Now, let Z be a plus bi be a complex number. In standard form. We call that standard form because it consists of the real part. This is the real part without I, and then this is the imaginary part, the one that coefficient with I has coefficient I. That's the coefficient of I. Okay. Now that's in standard form. Now we will rewrite z, which is a plus bi, as coordinate a comma b on complex plane. Complex plane is as the following. So it's just like a rectangular coordinate system, but instead of calling this x, they will call that the real component of a complex number, and this is the imaginary component of a complex number. Now a comma b will be presented as a coordinate a, b, okay, and that line, the blue line there, will be expressed as the magnitude of C. The amplitude, the magnitude of C. Sometimes we also call that the radius or the absolute value. Okay, so let me write it this way. The absolute value of C is called the absolute value the magnitude, the modulus, or simply the radius of complex numbers Z. And as you can see from the picture here, if that coordinate is coordinate AB, then this is A, this is B, okay? And therefore, the magnitude of C is equals to the square root of A squared plus B squared. Is it okay? Now, there is something called argument, the angle, in standard position. Call this angle theta. Okay, that's angle theta in standard position. That theta is called the argument of C. Okay, you can say if C is the coordinate AB, is represented by coordinate AB, then the argument of C is the angle in standard position from positive real axis. Okay, so I hope this actually remind you a bit about what we learned in chapter 1. Remind you a little bit of what we learned in chapter 1, where then if that's the setup, then you will see that A equals to R cosine theta, and the B equals to R sine theta. Where the R is this modulus here. This is R. Okay. So suppose on the other hand, we know the A and B. Suppose we know A and B, then the radius will be the square root of A squared plus B squared. That's something we have seen earlier. Okay, and the argument theta is equivalent, not equal to, equivalent to tangent inverse of B over A. You need to adjust. With the quadrant. Now, basically, what will happen then later on with all my explanation here, we already have earlier that C equals to A plus BI, right? Okay, now then later on we will re-express this in trigonometric form. R cosine theta plus I sine theta. Okay, we will re-express that way. So what I gave you here is actually the trigonometric form of a complex number. Now that's what we will learn a lot in this section. Not too much, but very crucial. Not too much, but very crucial. Okay. Now suppose, for example, I start working on problems. That's it. This section is only this. For example, I do problems on page 382. Let's say I do number 2. Let's say I do number 2. Number 2 is 3 minus 4i. The question is, first, graph on complex plane. Second, find the absolute value. Find the absolute value. Now, what is the graph? The graph will be 3, negative 4, right? 3 minus 4i, that's 3, negative 4. So approximately, this is the position. Okay. Then, this will be, the length of this blue line will be the magnitude. Okay, if I call this R here, then R equals to the absolute of that 3 minus 4i, which is square root of 3 squared plus negative 4 squared. What would that be? That will be square root of 9 plus 16, which is square root of 25. That's 5. Okay. Number 12. Number 12, we have 2 plus I. What we need to do is to graph, maybe to be more precise, find the opposite. Find the opposite. Second, find the conjugate. enter the graph, the position. Okay. Two plus I means 2 unit to the right, 1 unit up. So this is 2 plus I. Which is represented by 2 comma 1, right? Represented by 2 comma 1. Now, how about the opposite of 2 plus I? The opposite will be negative of 2 plus I, which is negative 2, which is negative 2 minus I. Now, if I sketch the graph, the position of that negative 2 minus I, it will be 2 to the left and 1 unit down. This is negative 2 minus I. Now you will see the opposite of a complex number is always 180 degrees from the origin. So it's like, you can think of it this way. The opposite of this here, you go to the other side of the origin. Okay, so the opposite of, if I pick a point here, let's say I pick a point here, the opposite of this will be that one. Okay, that's the opposite of the origin. You see what I mean? Okay, that's the opposite of the origin. Now, how about conjugate? The conjugate of a complex number denoted by, so we have 2 plus I. The conjugate has the notation of, you put a long line on the top. Okay, now the conjugate of a complex number will be the same real part, but the imaginary part, you get the opposite. The imaginary part, you take the opposite. Okay, the real part the same. Imaginary part, you get the opposite. So if I plot that on this coordinate plane, you will see that the conjugate actually have the same x, but opposite y. Okay, this is 2 minus I. Okay, in coordinate, that's 2 comma negative 1. Okay, you will see that you don't need this now, but it will be nice to know that the relationship between a complex number and the opposite, okay, there will be opposite of the origin. Now, the relationship between a complex number and the conjugate, that will be reflection, reflect with respect to real axis. Okay, do you see that here? You reflect that with respect to the real axis. So the real part will be the same. The imaginary part will be the opposite. Okay. Now, how about number 20? Number 20, we have a complex number in trigonometric form. 4 cosine 30 degrees plus I sine 30 degrees. Now that's the trigonometric form, right? Suppose we are given a complex number in trigonometric form. What will that be in a plus bi in standard form? Then let's change that value first. Cosine 30 degrees square root of 3 over 2. Sine 30 degrees 1/2. Now I distribute the 4. I get 2 radical 3 plus 1/2 I. Oh, I'm sorry, 2I, not 1/2, plus 2I. Okay. But if I try to picture that though, if I try to picture that, actually I don't know this. If I try to picture that, the position of 2 radical 3 comma 2, 2 radical 3 comma 2 will be here, okay, approximately here. That's 2 radical 3 comma 2. What it has to do with the radius and the angle. This is the radius. This is the angle. Okay, now what it has to do with those. Now suppose I pull this line here from origin to that coordinate, then the 4 will be the length of this line. That's the 4. And 30 degrees will be the angle from the real axis. That's the relationship. Okay, that's the 4. That's the 30 degrees. Now, because the angle 30 degrees here will be the same with the angle here, always, then we may rewrite this. You will see that our textbook sometimes use this notation. I do too. I may write it as 4 cis 30 degrees. Okay. Now, this cis actually stands for cosine I sine. That's where the cis coming from. Okay. Now, what we learn in this number 20 is to convert the trigonometric form into the standard form, which is actually on the easy side. Okay, which is actually on the easy side. Number 26, for example. Number 26. We have radical 2 cis 315 degrees. Now, what will that be in standard form? And we understand the radius is square root of 2. This is cosine 315 degrees plus I sine 315 degrees. That's what cis stands for. Okay, not cosine, but cis. This cis here stands for cosine plus I sine of the same angle. Now then, I will compute. What is cosine 315 degrees?
Square root 2 over 2.
That will be square root
2 over 2.
2 plus I times what is sine 315 degrees?
Square root 2 over 2.
Negative square root of 2 over 2. It's in quadrant 4, right? Cosine is negative. Now then, I will distribute the radical 2. I get 2 over 2 minus 2 over 2i. Well, which is 1 minus I, right? Such that when I sketch that on rectangular coordinate system, okay, now the coordinate 1 minus I will be here. Okay, 1 minus I will be there. Now, if you observe the angle here is 315 degrees. And the length here will be square root of 2. Well, because this is 1 here and that's another 1 here, right? Okay, so the radius will be square root of 2. Okay, But what we really need to learn from what we have right now is how to go backward. Suppose we have standard form, how to get the trigonometric form. Okay, how to get the trigonometric form. Now, so suppose, for example, I do number 38. Number 36 first. Number 36. 1 plus I. So we have invisible 1I here, right? Okay. Now then, how about the radius? The radius will be square root of 1 squared plus 1 squared. Okay, that's square root of 2. Now, how about the argument, the angle? They are not equal, but it is, we can get the value. That's this guy here, 1, comma 1, is in quadrant 1, right? 1 plus I, that's in quadrant 1. Are you with me? Okay, so that's equivalent to tangent inverse of the y over the x. Tangent inverse of 1 is 45 degrees, right? Okay, now so the question is theta exactly equals to 45 degrees or simply equivalent to 45 degrees? Is it exactly equals to 45 degrees or equivalent but not equal to 45 degrees? Then we ask ourselves, 45 degrees is in quadrant 1. Is it the same to where we expect that complex number to be? That's in quadrant 1 also, right?
Yes.
Okay, that's in quadrant 1 also. Okay, so then 1 plus I equals to the radius square root of 2 times cosine 45 degrees plus I sine 45 degrees. Okay. That's because we know theta is in quadrant 1 from that picture. Now, contrast this with number 38. Number 38. Number 38. We have negative 1 minus I. Now you will see, can you compute the radius? That's negative 1 squared plus negative 1 squared, right? Negative 1 squared plus negative 1 squared. That will be square root of 2. Now the thing is, which quadrant is this located? Negative 1 is here. Right? Actually, from the picture, you can tell right away the angle is what? Just from the picture. The angle is 225 degrees, right? But how do we get that though? Here's the thing. So we say theta is equivalent to tangent inverse of the y over the x. which is tangent inverse of 1, which is 45 degrees. Okay, but the thing is, we know our theta should be in quadrant 3, not in quadrant 1. Okay, we know the theta is in quadrant 3, not quadrant 1. So with the adjustment, what will my theta be? That will be 225 degrees. I add 180 degrees. Okay, so then negative 1 minus I is equals to square root of 2 cosine 225 degrees plus I sine 225 degrees. Oh, by the way, we usually write it as square root of 2 cis 225 degrees. On here, square root of 2 cis 45 degrees. Okay. Now, I want you to do some problem. There are times, however, once you sketch it, you know the theta right away. There are times, okay, but at least for example, one of the questions you see later is, for example, number 42. Number 42, negative 8i. Yeah, this is basically 0 minus 8i, right? Okay, now when you sketch that, the position is here. Okay, the position is here. So what is the radius? That's the distance. Radius. Distance from origin to that point is 8. I mean, by just looking at that, right? And the theta will be, that's right, 270 degrees. Okay, so negative 8i in trig form is 8 cis 270 degrees, like that. Okay, now let me ask you to do number 40, 43, 45, and 46. Number 40, 43, I'm sorry, 40, 40, yeah, 40, 43, 45, and 46. Okay, 1, 2, 3, 4. Let's say I give you 5 minutes. Okay, let's try number 43. Number 40. Sometimes you sketch that, you can see that right away. 5 plus 5i. Oh, the position is 5 to the right, 5 up. So it must be 45 degrees, right? It must be 45 degrees here. And the length must be 5 radical 2. So r equals to 5 radical 2. The theta is 45 degrees. Of course, you can do all those routine using the formulas, but you're supposed to get this. Therefore, the trig form will be 5 radical 2 cis 45 degrees. Okay, number 43. Number 43, negative 9. Negative 9, the position on complex plane is here. That's the position. Now, the distance from the origin is
9.
9. How about the angle?
The angle 0.
No.
No?
From positive x-axis.
Oh, that's
Positive
180, my bad.
Yeah,
I thought
180
we were asking
degrees.
for something else.
Yeah, okay. So 180 degrees. So negative 9 in trig form will be 9 cis 180 degrees. Number 45 will make us a bit busy. Why? Because I cannot really tell right away. Maybe I can, but I'm not sure. 2 plus 2i radical 3. So 2 to the left and 2 radical 3 up. So approximately. I don't know what's the R, so I need to do the routine. -2 squared plus 2 radical 3 squared. That's square root of 4 plus 4 times 3, that's 12. So the R is 4. Now, how about the angle? The angle theta is equivalent to tangent inverse dy over dx. That's tangent inverse of negative radical 3, which if you use calculator, it will give you negative 60 degrees, right? But you can tell from here, the angle is not supposed to be negative 60 degrees. That's important too. So what will theta be?
120.
120 degrees. That's why I say you need to do adjustment. Okay, you cannot say theta is negative 60 degrees. No, they're not equal. Okay, that's why I purposely use this sign here. Okay, it gives you the idea, but they're not equal. Number 46. Number 46. Negative 2 radical 3 plus 2i. The r will be square root of negative 2 radical 3 squared plus 2 squared, square root of 12 plus 4, that's square root of 16, that's 4. Oh, the same thing. And then how about the theta? We know the theta should be in quadrant 2, I believe. So somewhere on here, right? The x is negative, the y is positive. So theta is in quadrant 2. But then when I apply that formula, tangent inverse of y over x, I get tangent inverse of negative 1 over radical 3, that's negative 30 degrees. But I need quadrant 2. What is theta? (150 degrees). Okay, you will see that if I do adjustment, I need to add 180 degrees. Okay, because negative 30 degrees here, negative 30 degrees, right? Then if I adjust, I just add 180. Okay, that's for number 46. I'm actually done with this section, but let me go ahead further. What happens if we have very ugly numbers? Let's say, for example, number 48. Number 48, the complex number 3 minus 4i. 3 minus 4i, 1, 2, 3, 4 units down. This is minus 3 minus 4i. What is the length? What's the modulus? What's the radius?
Is it 5?
Yeah, 5, that's right. Okay, because it's triplets, right? The thing is, how about the theta? The theta is equivalent to tangent inverse of the y over x. That I need to use calculator. I will get negative 53.13010 degrees. Okay. And according to our picture, yes, it is in quadrant 4, right? Okay, so 3 minus 4i, 3 minus 4i is equal to 5, 6, negative 5, negative 53.13010 degrees. Okay, got to 4, 6, 153 for number 46. For number 45, execute plus 2I value is 4, 6, 120. Okay. Now, of course, I believe our textbook does not like negative angle. Then you can adjust this. Look at the coterminal. This is 5, 6. You add 360 degrees. 360 degrees, that would 306.86990. Okay. If it is not in the quadrant you want, let's say it's supposed to be in quadrant 2 instead of quadrant 4, then what do you do to this angle? If what I have is -3 plus 4i, and then when you do the tangent inverse, you get this number, but you need the one on that side, let's say, then you add 180 degrees. Okay, if you need to do that kind of adjustment. From quadrant 1 to quadrant 3, you add 180. Quadrant 2 to quadrant 4, you add 180. From quadrant 4 to quadrant 2, you add 180. Basically like that. Okay. That's basically it that I need you to study. But for this 8.4, especially this 8.4, I need you to be super strong. I'm sorry, not 8.4, 8.2. So on 8.2 suggested homework, 8.2, number 1 to number 33, you can do every other odd. Okay, however, from number 35 to number 54, I want you to do all. A lot of practice, okay, a lot of practice. Now let's see how we will use this in 8.3. Okay, let's see how we will use this in 8.3. I use another color. In 8.3, we will use it in the following way. Now, suppose Z1, a complex number, is radius times the angle, the cis of the angle, and C2 equals to radius 2, cis theta 2. So I rewrite my complex number in trigonometric form. Then the product of these two complex numbers will be the product of the modulus times cis of the sum of the angles. Okay, so what will happen is later on, I give you complex numbers in standard form. What you need to do is to convert them into trigonometric form, and then you can use this formula, and then you go back to standard form. Okay, that's why you need to be able to convert that into trig form, trigonometric form. Now, furthermore, suppose for example, I have z to the n, basically z times c times c times c times c. That will be r to the n cis and theta. So the radius take to the same power, the angle multiplied by the same power. Not taken to the same power, but multiplied by the exponent. The exponent we have here. We do the same to the radius, okay? But the angle we multiply. Okay? That's a little few that you will see on Monday. But for that to happen, you need to be super strong on this. Okay? You need to be super strong on that one. Okay, then. That's for today.
Thank you, Professor.
You're very welcome.
Thank you, bye.